Here we've got a classic AP Calc question where they're starting us off with f of x, which is a piecewise function, and then what they want us to do is determine which of the following statements below are true statements. So which of the following statements are true? So this is their classic way of getting us to do two problems in one, or I guess in this situation, three problems in one. So we'll just start at the beginning here and work through each of these little individual pieces and see which ones are true or not. So looking at I right now, it would want to know, is the limit as x approaches 1 from the left of f of x, does that equal the limit as x approaches 1 from the right of f of x? Well, what we need to do is figure out which equation up above we would want to use for each of those situations. So looking at the first one here, this would be a left-hand limit because we've got that negative on the 1 there. So things to the left of 1 would end up being this top equation. That's things that are less than 1. So we're now being asked really, is the limit as x approaches 1 from the left of 3x minus 3, does that equal? And then on this side, we've got a right-hand limit because we've got the plus. Things to the right of 1 are things that are greater than 1. So for that side of the problem, we'd want to know what's the limit as x approaches 1 from the right, and we would be doing the natural log of 3x minus 2 for our equation there. Now, to evaluate these limits, you're just going to apply what I just call option 1. You're just going to take that x value and plug it into the equation. So on this side over here, we would get 3 times 1 minus 3. 3 minus 3 is going to get us 0. And we want to know, does that equal, on this right-hand side, again, plugging in 1 for this equation, we would have gotten out that this is equal to the natural log of 3 times 1 minus 2. So that would have been the natural log of 1. The natural log of 1 is something they just expect you to know. The natural log of 1, the log of any 1 is always 0. So the natural log of 1 equals 0. And so what we can see here is that our left-hand limit and our right-hand limit do equal each other. And so that would be a true statement. So right now we know that 1 is for sure a good answer, which means that anything that doesn't have 1 in it right now, you can throw those out as even options on the table. Now we'll go on to the next piece. So on to option 2 here. Now what we're doing limit as x approaches 1 from the left of f prime of x. And does that equal the limit as x approaches 1 from the right of f prime of x? Well, lucky for us now, we get to take two derivatives to plug into this equation. So looking at my left-hand derivative here, my LHD, that would be, again, this top equation. So if I look at finding the derivative of that, this would be 3x minus 3. So the derivative of 3x minus 3, if we follow our power rule, bring the power down, subtract 1 from the power. So 1 times 3 is 3. X to the 0, anything to the 0 power is 1, so we don't need that. And then the derivative of negative 3 would go away. So on this left-hand side right now, we have the limit as x approaches 1 from the left. And instead of f prime of x, we now know what it is on the left. That is 3. And then the limit of 3 is 3. So we know the left-hand side, that's equal to 3. Now we're going to come back and we're going to do the same thing on the right-hand side. So now we need to come and use the right-hand equation. So that would be f of x is equaling our natural log of 3x minus 2. So if f of x equals the natural log of 3x minus 2, this is first and foremost what I refer to as a special case derivative. So there's certain derivative rules that you just have to have memorized. One of them is the natural log. So if f of x equals the natural log of x, then the derivative of the natural log of x would be 1 over x. However, on all of these special cases, as soon as this becomes anything more than just an x up inside there, and anything more than just a basic x, 3x, negative x, anytime it's more than just x, it becomes a chain rule problem. And so in order to find this derivative, because we have something more than an x inside our natural log, I need to follow the chain rule recipe. So my chain rule recipe goes d in times d out, the derivative of whatever I plugged inside that original function times the derivative of that outside function, which behaves like it normally would. So on this one, the inside is 3x minus 2. So f prime of x, the derivative of 3x minus 2, following the power rule, the derivative would be 3, and then the x goes away, and the negative 2 goes away, bringing that 1 down, subtract 1 from the power. And now we would take the derivative of the outside on this natural log. And so the derivative of the outside on this natural log is going to give us that we've just followed the rule here. So the rule for natural log is going to be 1 over whatever was on the inside. So 1 over 3x minus 2. So the derivative on this right-hand equation is going to end up giving us 3 over 3x minus 2. So if I come down here and go limit as x approaches 1 from the right, and now I'm plugging in my derivative, which is 3 over 3x minus 2, then I come in and now I do option 1, which is go ahead and plug that in. The other one was a constant, so we didn't have to go through this process. But here we have an actual value to plug in. So we would take and plug in 1 for x. So that would be 3 times 1 minus 2. So we would end up getting 3 over 1, which would equal 3. And so here we can see that this side was 3 and the other side was 3. So those two things are equal. So again, we know that that statement is true. So 1 and 2 are both true right now. And then when you look at that, you know that if 1 and 2 are true, then A can't be it. And then the only other options were just down to C and D. Sometimes on these, that's enough to tell you what the right answer is. But we don't get that lucky on this one, and we have to go on to 3. So is it differentiable at this point? And so to see if something is differentiable, we have to know what that means. So for it to be differentiable, two things have to happen. One, the left-hand derivative needs to equal the right-hand derivative. We call that being smooth. This is how you tell if you've got corners or cusps going on, things that are bad. And then the second thing we need to know is that it's continuous at that point, so that we would not lift our pencil at that point. Well, the continuous piece we got out already. We essentially showed that it was continuous back at the beginning because we found that our limit as x approached 1, our overall limit, you find that by saying, does the left-hand limit equal the right-hand limit? We found that the left-hand limit and the right-hand limit for this equation both equaled 0. And so we know that the limit was equal to 0. And to find if it's continuous, continuous means the limit, which we just found there, has to equal what I call the dot on the graph, the function value. So if I wanted to know what is f of 1, I would be plugging into the bottom equation, which is essentially what you did finding the limit, right? So this would have been 3 times 1 minus 2. So out of there, we would have gotten the natural log of 1. So f of 1 would have equaled 0. So we know that it's continuous. So this part of it is at least true. And then to do number 1, does the left-hand derivative equal the right-hand derivative? Well, we did that really on part 2 right here. We found that our left-hand derivative was going to equal 3 once we plugged it in. We also found that our right-hand derivative was going to end up equaling 3. And so those two things are equal. And so that told us that part 1 of this was true. So the first part is true, the left-hand derivative equals the right-hand derivative, and the second part was also true, it's continuous at 1, and so we know that option 3 here is also true. At 1, this equation is differentiable. So 1, 2, and 3 were all true, which tells us option C is our good answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.